Students, let us continue with the MCQs part 2 for polynomials. Here is the first question for today's class. If the sum of the zeros of quadratic polynomial 3x square minus kx plus 6 is 3, then what's the value of k? So to answer this question, first list out the key points here. They have given us sum of the zeros as 3 and they are asking to find the value of k here. So let us see what we had learned earlier. We had learned that when the quadratic polynomial ax square plus bx plus c is given, we know that sum of zeros alpha plus beta is given by minus b by a. Similarly, product of zeros can be written as alpha beta, that is equal to c by a. So here, since we have given with sum of zeros, let us just write it over here. Alpha plus beta, that is equal to minus b by a, that is equal to 3. So here we can get the values of b and a from the quadratic polynomial. Therefore, let us list out what are the values of a and b. A is equal to the coefficient of x square, that is 3, as well as b is equal to the coefficient of x, which is minus k here. Now let us use these values of a and b here in the first equation. We have minus b. So minus of b value is minus k. Therefore it is minus of minus k divided by a is 3. So minus of minus k by 3, that is equal to 3 in the RHS. So when we simplify this one, we will get minus into minus plus k is equal to 3. When we take the 3 from the denominator of the left hand side, it becomes into 3. So k is equal to 9. Students, be careful because in a hurry, instead of writing the answer 9, you might write 3 into 3, that is equal to 6. And this is wrong. Why I am saying this? Because in the option you have 6 as well as 9. So the correct option which you have to choose is the option A, that is 9. Students, will move on to the next question. Here is the next question. So we have given with the graph of the polynomial p of x intersects the x-axis at 3 distinct points. Then we have to say what type of the polynomial p of x is. So to answer this question, let us see what we know. So we know that zeros of the polynomial p of x, that is equal to the degree of the polynomial. Same polynomial I have given here, that is nothing but the polynomial p of x. So what they have given here, the given polynomial intersects x-axis at 3 distinct points. That is nothing but the given polynomial has 3 zeros. Therefore, what we can say here, we can say that degree of the polynomial p of x is 3 over here. We all know that when the degree of the polynomial is 3, then the polynomial is a cubic polynomial. Therefore, the answer is answer B, cubic polynomial. We'll move on to the next question. Here is the next question. The question is the zeros of the polynomial p of x 4x square minus 12x plus 9 are. So to find the zeros of this polynomial, we can go with splitting middle term method. So how to split the middle term? Minus 12x here, we have to take the sum as minus 12x and the product as the product of first and the last term, that is 4x square into 9, that is equal to 36x square. So now to split this, we have to find the numbers which gives you product as 36x square and sum as minus 12x. Since I have the sum as negative, I have two chances. When we add two numbers with one positive and one negative, we can get negative sign of the sum when we have greater number as negative, as well as we can get the negative sign when we have both the negative numbers. Okay, so these are the sign conditions for sum can be negative. Correct? Now we have a product as positive. So what are the conditions for product to be positive? So here, when we have both positive signs, we can get product as positive, as well as when we have both negative, we can get the product as positive, right? So observe that we have the sign sets here for sum and product. Check which is applicable for sum as well as product. So the sign set negative negative is applied for both sum and product. Therefore, the sign of factors should be negative and negative. Now, let us see the numbers here. We have 36 and 12, right? So, when we can get 36 as a product and 12 as the sum. So, if we take the numbers as 6 and 6, we can get the product as 36 because 6 6 are 36, as well as when we add minus 6 and minus 6, we will get minus 12. Therefore, the factors are minus 6x minus 6x. Therefore, let us just apply this one in the polynomial here. What we have given with? We have 4x square minus 12x plus 9. As the name indicates, we are going to split minus 12x here. So we can write 4x square and plus 9 as it is. And the middle terms can be minus 6x and minus 6x. So here minus 6x minus 6x. So here by grouping the two terms together, we can just simplify this problem. We can write here as 2x, which is common in the first and second term. When we take 2x common out, the remaining is 2x here. And in the second term, the sign is negative. X is already taken out. So 2 3s are 6. Remaining in the bracket is 2x minus 3. So in the second set, we have minus 3. Why it is minus 3? Because both 6 and 9 are divisible by 3 here. In the bracket, 3 2s are 6. Therefore, it is 2x because we don't have x here in the 9 or with the 9. So, we can't take x common out. Therefore, in the bracket, we remain with 2x and minus 3. So, if you are getting with the sign confusion, what you have to observe is the first bracket should be same as the second bracket, or you can say that the second bracket should be same as the first bracket. Now, let us write the factors for it. Factors are 2x minus 3 into 2x minus 3. Since they are asked to find the zeros of the polynomial, we can equate these factors to 0. Therefore, we'll get the zeros by equating each of the factor to 0. That is 2x minus 3, that is equal to 0. Therefore, 2x is equal to 3 and x is equal to 3 by 2. Observe that here we have the same factors. Therefore, the zeros are also same. We can write x is equal to 3 by 2 and x is equal to 3 by 2. Therefore, what are the zeros? Zeros are 3 by 2 and 3 by 2. Therefore, the answer is answer A. we'll move on to the next question. The next question is, we have given with alpha and beta are the zeros of the polynomial 2x square plus 5x plus 1. Then the value of alpha plus beta is. So if you observe here, they have given that alpha and beta are the zeros of the polynomial and they are asking for alpha plus beta plus alpha beta. If you remember, what is alpha plus beta? Alpha plus beta are the sum of zeros and alpha beta is the product of zeros. Therefore, we can find the answer for the given question by finding out the sum and product of zeros. So let us recall what is sum of zeros. Sum of zeros is given by alpha plus beta, that is equal to minus b by a, and product of zeros alpha beta, that is equal to c by a. So let us first list out what are the values of a, b and c from the given polynomial. What's the value of a here? Value of a, that is equal to 2. Value of b is equal to 5 and value of c is equal to 1. So let us just apply this here for the sum of zeros and product of zeros. Therefore, alpha plus beta, which is equal to minus b by a, that is equal to minus 5 by 2, as well as alpha beta, that is equal to c by a, that is equal to 1 by 2 here. Okay, so let us now substitute the alpha plus beta and alpha beta values in the given equation. That is alpha plus beta plus alpha beta. So here group alpha plus beta and alpha beta, which is equal to minus 5 by 2 plus 1 by 2. So when we simplify this one, I will get here 2 in the denominator and in numerator minus 5 plus 1. The answer is minus 4 by 2, that is equal to 2 ones are 2 twos are. So the answer is minus 2. Therefore, the option A is the correct answer. Let us move on to the last question of this class. Here is the question. We have given with if minus 1 is the 0 of the polynomial f of x square minus 7x minus 8, then the other 0 is. So observe that we have given with one of the zeros of the polynomial. What we can do here, we can consider one zero as alpha is equal to minus 1. Therefore, they are asking what is the value of beta. So how we can find this one? Just let us recall, we know the relation here, that is alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. So using any of this relation, we can find the value of another 0. So first, let us see how we can find the value using sum of zeros. So that is equal to alpha plus beta, which is equal to minus b by a. First, let us list out what are the values of a, b and c in this problem. A is equal to the coefficient of x squared, that is equal to 1. B is equal to coefficient of x, which is equal to minus 7. So here you need to take the negative sign along with the number. And C is equal to minus 8. Even here also we have to take the negative sign along with the number 8. Okay, so let us simplify this problem. Alpha plus beta is equal to minus b by a. So we have the alpha value as minus 1. So minus 1 plus beta, that is equal to minus of minus 7. Why it is so? Because we have the negative sign in the formula as well as we have the b value negative 7. Therefore, it is minus into minus 7 divided by 1, that is equal to minus into minus is plus. So we will get minus 1 plus beta, that is equal to 7. This implies beta is equal to 7 plus 1, that is equal to 8. So we got another 0 as 8 by using the sum of zeros is equal to alpha plus beta, that is equal to minus b by a. Now let us see how we can find the value of another 0 using the product of zeros concept. So we know that alpha beta, that is equal to c by a. So what is alpha here? We have alpha as minus 1 into beta, that is equal to c by a. Our c value here is minus 8 divided by a is 1. So here beta is equal to minus 8. Here in the left hand side, minus 1 is getting multiplied with beta. Therefore, when it goes to the other side, it becomes divided by minus 1. So, minus and minus gets cancelled. This implies that beta is 8. So, whatever the method you use here, but you will get the same answer for the beta, that is 8. Therefore, the answer is option B, 8. So, hope you understood today's class. Guys, keep watching, continue learning. Let us meet in the next class. Thank you.